All right, guys, we're going to go on and get started. So, note sheet from yesterday, 3.3, note sheet from yesterday. 3.3, the note sheet from yesterday. I think it was a bad. I cut it out of something, but didn't cut well. All right, guys, let's focus in. All right, guys, let's focus in. So, we did this at the end of the lesson yesterday, the square root method. And the way the square root method works is we want to get the squared term by itself. All right, guys, focus up here. We want to get the squared term by itself. So here, our squared term is x squared. Now, the main way that the square root method works is in one of two cases. Either we don't have a middle term. There is no x to the first power, or x without an exponent, which we do not have here. The only one we have is x squared. The other case is that the only variable is inside of a set of parentheses being squared. Are the two cases this works. So this does work here. So the first thing we want to do is get that x squared term by itself. Okay. All right. That works. Let's see here. That's funny. There we go. So we want to get the x squared term by itself. So the first thing we can do is add 9 to both sides, because we want to get the x squared, in this case, by itself. So we can add 9 to both sides. Questions on this so far? Is the x squared term by itself? No, what do we have with it? 3. So we're going to divide both sides by 3. Now 3x squared divided by 3 is x squared. 9 divided by 3 is 3. Did we get the x squared term by itself? Step number 2. Take the square root of both sides. We need to take square root of both sides. Now for the left-hand side, that's kind of nice, because the square root of x squared is x, because the square root and square will simplify out. Now whenever we take an even root of both sides, we take the square root of both sides. We have to add the plus or minus, because we can have the positive or negative case. Question? Okay. Now we need to find the square root of 3. Well, luckily the 30xs will simplify radicals for us if they are simplifiable. And all the square root of 3 is square root of 3. Questions on this so far? We're ready for step number 3. Solve for x. We want to solve for the variable. Is x by itself?
Yes.
So that's it. As if x is not by itself at this point, we do need to solve for it. But here, x is by itself, so we are done. So, questions? Yeah. Questions? Yes, sir. So the 2, so the square is dealing with the property of it. So where the square went with this here It's talking about the square root because we're taking the square root of x squared. X squared, whatever x is, when we square it, is being multiplied by itself. When we take a square root, we're trying to say what times itself is inside here. So those two counteract each other. Because x squared, x is being multiplied by itself. Squared is saying what is being multiplied by itself. Well, that is x. They undo each other. Does that make sense? It's kind of the same thing as saying, what is the square root of 3 squared? Is just 3. It's the same thing with x squared. The square root of x squared is x. They cancel each other out. Does that make sense? Questions on this here? We ready for the next one? Two-fifths times x plus 3 squared equals 5. Interestingly enough, we can still use the square root method on this because the only place where we have a variable is inside of that set of parentheses that's being squared. So it still works. The only time we wouldn't have or wouldn't be able to solve a problem like this here is if we had x inside the parentheses being squared and outside. Then we would actually have to simplify that parentheses, multiply it out, and get the x's together. But luckily for us, the only place where x is inside the parentheses, yes? Now let's look at our first step. What is our first step in solving this? Get this term, get the squared term by itself, yes? Probably yesterday and still when we wrote that first step out, that seemed a little weird. Why would we say squared term and not just the variable being squared? Because here, we don't just have a variable being squared, we have a term. The x plus 3 is being squared. Still works the same because that whole term is being squared. We need to get it by itself. So what is with our squared term? 2/5. We need to get it to the other side. How can we get the 2/5 away from our x plus 3 squared? Well, we can't necessarily minus.
What is it?
It is divide. Because the 2/5 and our x plus 3 squared are being multiplied. So to undo multiplication, we have to divide. Because our 2/5 divided by 2/5 is 1, leaving us with x plus 3 squared. And what we do to one side, we have to do to the other. So we have 5 divided by 5/2. 5 divided by 5/2 is, did I type that in wrong?
Yeah. Because you already had it up there.
2/5. 5 divided by 2/5 is. Well, so we're dividing 5 by 2/5. So what I did is I accidentally flipped the 2/5 to 5/2, which gave us the wrong answer. And unfortunately, that mistake's going on YouTube, so. But we can fix it. So, questions on this here so far? Okay. So what was our first step to get the squared term by itself? Yes? Is the squared term by itself? Yeah. Because even though we do have x plus 3, the x plus 3 is inside that squared term. It's a part of it. So really what we needed to do was get the things being multiplied out front, and anything that was added or subtracted to those parentheses to the other side, we needed to get them away from it. Because we do have x plus 3 being squared. That whole term is squared, yes? So if I applied the second step to it, all right, guys, if we took the square root of x plus 3 squared, well, the square root and squared would cancel out, leaving us with x plus 3. So even though we do have x plus 3, because it's entirely in that set of parentheses being squared, we can square root it and get rid of that power. Does that make sense? Yes? Kind of. Because really we're saying that this x plus 3, this whole term is being multiplied by itself. So the square root of it cancels it out. Because that's the nice thing about squares. Now, what we do to one side, we have to do to the... So I take square root of 25 halves. Second square root. 25 halves is... So, the calculator won't simplify it as a whole, but... All right, guys, let's focus in. Square roots of 2 over 2. Now, the calculator will, the 30xs will simplify fractions with radicals, but we've got to break it up and take the square root of the top over the square root of the bottom. That's the only way it'll simplify. Now, 5 square roots of 2 over 2 is indeed our same decimal, but we're going to leave it as 5 square root of 2 over 2. And whenever we take an even root, a square root of both sides, we still have to add the plus or minus, because our 5 square roots of 2 can be positive and it can be negative. Because whenever we take an even root, we have the positive and negative case. Questions on this here? So, step number 3, we've kind of, it's been there. Solve for x. Is x by itself? Bless you. Well, no. Here we have what? X plus 3. So, this one here we do have to solve. We have to subtract 3 from both sides. Because our 3 minus 3 will cancel. Whenever we add or subtract at this point, we want to put whatever that number is in front of the plus or minus. So when we took the square root of 25 over 2, we're trying to find what times itself is that amount. Now, I'm going to flip over here. Because our 5 square roots of 2 over 2 squared is indeed gets us back to our 25 halves. So our answer is indeed positive 5 square roots of 2. Now we also have negative 5 square roots of 2 over 2. Do want no. Negative 5 square roots of 2 over 2. And if we square this, we multiply it by itself, we also get 25 over 2. So the square root of 25 over 2 is positive and negative 5 square roots of 2 over 2. The plus or minus? Yes, because if we take the square root of both sides, we need the positive and negative case. Any other questions on how we got to this point here? All right, guys. All right. Focus up here. Questions on this here? Are you ready for the next one?
Yes.
2/3 x squared plus 14 equals 20.
Divided by 2. No, but no. Okay.
Yes.
Minus 14.
Yes. Yes.
Oh, minus 14.
Because we can divide by 2/3, but I would wait till we get the squared term by itself. So again, the first thing we need to do is get our squared term by itself. So the first thing we can do for this here is subtract 14 from both sides. If we subtract 14 from both sides, we get that 2/3 x squared is equal to 6. Is our squared term by itself? What do we need to do next? Both sides by 2/3. Which gives us x squared by itself. Now we can do 6 divided by 2/3 is 9. Is the squared term by itself? Yes. Mm-hmm.
Wrong. I thought you meant
Nice. Be nice. So x squared, there's nothing being multiplied in front of it or added to it, so it is indeed by itself. So we can take the square root of both sides. Now our square root of x squared, the square root and square would cancel out, leaving us with x by itself. Now the square root of 9 is 3. And since we took the square root of both sides and even root of both sides, we have to add the plus or minus. Questions on this here? Now this did give us a nice answer, positive or negative 3, yes? So I'm going to get it equal to 0. So I kind of jumped a step. Really, all I did was subtract 20 from both sides to get it equal to 0. Because if I'm going to graph it factored, I need this equation equal to 0. Okay. Grab the graphing calculator. Y equals, figure that out. So y equals enter 2/3. All right, guys, let's focus in. So when x is negative 3, the graphing calculator tells us the y value is 0, so x equals negative 3 is a solution. When x is positive 3, the y value is, so we could have graphed this and got the same answers. Because if we do get integer answers, we could have graphed it and gotten the same thing. Questions on this here? I'm ready to look at one more using the square root method. Oh, well, 2 more actually. We got this in one more. First thing we need to do is get the squared term by itself. So what can we do first? So we can subtract 1 from both sides, which will tell us that negative 2x squared is equal to negative 7. What can we do next? Divide by negative 2. And when we divide both sides by negative 2, our negative 2x squared divided by negative 2 is x squared. Negative 7 divided by negative 2 is 7/2. We could turn it into a decimal, but it's going to be easier to reduce or keep it in simplest radical form if we leave it as 7/2. X squared's by itself, so we can take the square root of both sides. Now our square root of x squared is x. Since we did take square root of both sides, we will have our plus or minus. And our 30xs, we can plug it in, but we have to take the square root of the top divided by the square root of the bottom, and it will simplify it for us. And the reason it's simplifying is we can't leave a radical in the bottom of a fraction. We can't leave the square root of 2 in the bottom. But it does simplify it too. Square root of 14 over 2. Yes. And that's mainly with even roots. So square root, fourth root, sixth root. If it's an odd root, a cubed root, we don't have that. It only works with even roots. And since x is by itself, that's it. That's our final answer. Questions on this here? We're ready for the next one. Two times x minus 4 squared is equal to negative 5. X is only inside our parentheses, so we can use the square root method on this here. What's the first thing we can do to get this by itself? Divide both sides by 2. And we divide both sides by 2. It'll tell us that x minus 4 squared is equal to negative 5 halves. Our squared term is by itself, yes? So we can take square root of both sides. On the left-hand side, our square root and square will, leaving us with x minus 4 is equal to plus or minus the square root of negative 5 halves. So we can say the square root of negative 5 over the square root of 2 is domain error. Okay. Well, square root of 5 over 2 works, but that's not what we're taking because we need the negative either in the top or bottom. It doesn't work. Well, it's not that it's no solution, it's no real solution. There is a solution for it, it's just not a real number. And we're going to start finding those solutions after fall break. Now, I'm going to go on and graph this. So to get it equal to 0, I would just add 5 to both sides, giving us 2 times x minus 4 squared plus 5. All right, guys, focus in. Graph. So this here is the graph of that equation. Where does it cross the x-axis? So there is no real solution. We'll come back to those after fall break. Questions on this here? Are you ready for the next one? All right. So we've done these before. We've done some factoring already, our 3.13. We're just going to look at factoring a little bit here. If we want to solve this by factoring, we need to get this equation equal to what? 0, because there's only been one method so far where the equation didn't need to be equal to 0, and that's been the square root method. So the first thing we need to do for this here is get this equal to 0. So to do that, we can subtract 45 from both sides, which will tell us that we have x squared minus 4x minus 45 is equal to 0. Now we can start factoring. And our first step in factoring is to find the greatest common factor. What is our greatest common factor between these three terms? Well, there's not one. There's not one other than 1. So we can move on to our second step, our 2 sets of parentheses with 3 spaces. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. So our third term sign is negative. So one's going to be positive, one is going to be negative. Our next step is find the factors of the first and third term. Well, the only factors for x squared are x and x. Factors of 45. 1 and 45, 3 and 15, and 5 and 9. Which one of these three do we want to try first? 3 and 15? Okay. Welcome. And last thing we need to do is check and make sure before we solve. X times negative 15 is negative 15x. 3 times x is plus 3x, giving us negative 12x. Is that the middle term we wanted? No. We could flip the 3 and 15. All that's going to do is change it from negative 12x to positive 12x. So what can we try next? 5 and 9. So 5 and 9. And if we check this here, x times negative 9 is negative 9x. 5 times x is plus 5x is equal to negative 4x. Is that the middle term we wanted? Yes. Now, since we do have two things multiplied together to equal 0, one of them has to be what? 0. So either x plus 5 is equal to 0 or x minus 9 is equal to 0. Now at this point here we can 5 from both sides, telling us x is equal to negative 5. With our x minus 9 we can add 9 to both sides, telling us x is equal to 9. Those are our two solutions. If we get two integer answers like this here, we could have actually graphed it and got that answer too. But it told us to factor. Questions on this here? We're ready for the next one. 3x squared minus 5x equals 2. And it wants us to solve by factoring. So we need to get it equal to 0. So the first thing we can do is subtract 2 from both sides. Telling us that 3x squared minus 5x minus 2 is equal to 0. I'll go on and tell you there is no greatest common factor between these three terms. So we can move on to our signs. The third term is negative. Since the third term is negative, our signs are opposite. They are different. One of them is going to be positive, one of them is going to be negative. Now we need to find the factors of the first and third term. So 3x squared. Well, x squared would be x and x. Factors of 3. Where do we want to put the 3? First one. Factors of 2. 1 and 2. Where do we want to put the 1? Where do we want to put the 2? 1 in the first, 2 in the second. And the last thing we need to do is check. 3 times negative 2 is negative 6x. Positive 1 times x is positive x. Negative 6x plus x is negative 5x. Is that the middle term we wanted? Yes. Your product property says if we have two or more things multiplied together to equal 0, one of them has to be 0. Either 3x plus 1 is 0 or x minus 2 is 0. Now with 3x plus 1, we just need to solve for x. First thing we can do is subtract 1 from both sides, telling us 3x is equal to negative 1. Now we need to divide both sides by 3. X is equal to negative 1/3. On the other side, x minus 2 equals 0. So what we need to do is add 2 to both sides, telling us x is equal to. Now, if we had graphed 3x squared minus 5x minus 2, the graphing calculator would have given us one of those two answers. It's given us 2, but it wouldn't necessarily have given us the negative 1/3. Questions on this here? I think that brings us to the last three problems, yes? So, finding the zeros. It seems like we're going to do something different, and we're not. Because when it says to find the zeros of this function, it wants us to find out what values of x will make this function be. That's what we've been doing, yes? It's just another way to say the exact same thing. We're just wanting to know what value of x is going to make 2x squared minus 11x plus 12 equal 0. Now, did it tell us or ask for a method for finding this? We can do any method we want. If I wanted to, I can go y equals 2x squared minus 11x plus 12. Hey, it intersects with the graph x-axis at two places, yes? Second table. What's one of our values of x that makes y value be 0? Is 4, yes? What's the other one? It's probably somewhere between 1 and 2, yes? Okay. It means we're going to have to factor. Now, this is kind of nice to know. If the graphing calculator does give you one of the two answers for quadratics, it is factorable. It is factorable. And it does kind of give us a hint. We'll see that here in a second. There is no greatest common factor. If the third term is positive, the signs are the same and match the sign of the middle term. So they are both negative. Now we're going to find the factors of 2x squared. We'll have x and x, 2 and 1. Factors of the third term, factors of 12. 1, 2 and 6, 3 and 4. Which one do we want to try first? 3 and 4. Because what did the graphing calculator tell us one of the solutions was? 4. Might try 3 and 4, yes? Because it does have one of our solutions. But the 3 with the 2x and 4 by itself over there with just x. Now we have two things that multiply together to equal 0, so one of them must be 1, 0, yes? So it's telling us that either 2x minus 3 is equal to 0 or x minus 4 is equal to 0, yes? I'm going to solve the x minus 4 one first. What can we do first? Negative 4 plus 4 is 0. 0 plus 4 is? Well, lo and behold, we said that x is equal to. Isn't that what the calculator already told us? Yeah. Now we just need to find the other one. Well, the first thing we can do is add 3 to both sides, telling us that 2x is equal to 3. Divide both sides by 2. Well, 3 over 2 is 1 1/2 or 1.5, which is indeed between 1 and 2, kind of where the graphing calculator told us. It kind of did tell us the answer, but it didn't tell us exactly what it was. It told us what to expect, at least. Questions on this here? We're ready for the next one. Do y'all want to factor this or try graphing it? Try graphing it. Y equals, clear all that out, x squared minus 8x. We type it in and hit graph. That looks promising. Second graph, Again, we're looking for what value of x makes the y value be 0 and 8. So this is the one time where x can be 0 because the y value is also 0. Again, we're looking for what values of x makes the y value be 0. So x is equal to 0 and x is equal to Now I'm going to factor this also. This is because it's kind of a little bit special in a way. Because if we look at those two terms, x squared and negative 8x, our first step in factoring is to factor out the greatest common factor, yes? What is the greatest common factor between these two terms? Because there actually is one. That's the only thing it does have in common. They both have an x in common. Because up to this point, we've had x squared, an x term, and then a number, yes? So that number prevented us from factoring out a variable. Here, they do have a variable in common with both. We don't have that number, yes? So we can factor it out. Now, if I factor x out of x squared, we're left with x minus 8. We're essentially dividing an x out of both terms. We're removing an x from each one. Wait a minute. We do have two things multiplied together that equal 0, yes? So it's telling us that either x minus 8 is equal to 0 or x is equal to 0. That's done. X is already by itself. It equals 0. We're done with that one. The other one we would add 8 to both sides, so x is equal to. Done. Questions on this here? We'll leave that one for tomorrow. Homework is this here. We'll do that one problem tomorrow, and then we are done with 3-3.